Hi, my name is Richard Morin, and this is my Physics 2 Lab 3, Magnetic Field of a Bar Magnet. Introduction instructions. The instructions for this lab were to measure the magnetic field of a bar magnet at different distances, following these steps. Step 1, compensate the magnetometer for magnetic north. Step 2, find the magnetometer chip located in your phone through testing different locations relative to the bar magnet. Step 3, find the distance from the magnet for different given magnetic fields. Step 4, measure the off-axis magnetic field. And Step 5, coding to compare values. Purpose. The goal of this lab was to evaluate the magnetic field of a small bar magnet at different distances, comparing these measurements to the Biot-Savart law. Overall, though, the purpose of this lab was to learn more about the principles of magnetic fields, a topic that has been discussed extensively in class recently. Results preview. Through this lab, the magnetic field off-axis of a bar magnet was determined, both in an experimental and simulated coding aspect. The experimental magnetic field was determined to be 5.38 times 10 to the negative 5, and the simulated magnetic field was found to be roughly 2.45 times 10 to the negative 5. The main models and principles used in this lab can be seen below, to which there are three main equations. The first main equation is the magnetic field equation for B vector, which is used to find the magnetic field of a given object. This is particularly relevant to both the experimental and coding sections of this lab, being the main fundamental equation. The second equation seen was the equation used to graph the results from the experimental section of the lab, and the third equation seen was an alternative equation for the magnetic field of an object, and can be used to help find the magnetic moment of this experiment. Systems and surroundings. The system in this lab was a small bar magnet, the magnetometer, and all devices providing a magnetic field large enough to be detected by the app, albeit these were not meant to be a part of the experiment, but still had an effect within the system. And then the surroundings was everything else in the environment. Initial conditions. Magnetic north is accounted for, as the x component of the magnetic field on the magnetometer app was made as close to zero as possible. The bar magnet was oriented along the north-south axis that is made with the meter stick. There's only one magnet, and the magnetometer app being used is Physics Toolbox, and as little magnetic interference as possible occurred, as all electronics were moved away from the location of the environment, albeit it was impossible to fully remove all interference. Seen here is the experimental data achieved through my experiment. Notable things include distance and then also the magnetic field, in addition to the LNBX versus LNR graph seen on the right. At the bottom, the distance of 0.27 can be seen, and the magnetic field of roughly 5.38 times 10 to the negative 5 was derived. Experimental data analysis. The main analysis conducted was finding the magnetic moment, which can be seen through this rearrangement of the magnetic field equation, granting a number of 3.1369. Coding. Seen here is my coding. Included in the left picture is creating the magnet at the origin, and included in the right lower picture is a function for the magnetic field. These pictures help visualize the magnetic field on axis and perpendicular to the axis, creating the vectors seen in the image. Here's the results from my coding. On the left is the image generated by my code, and on the right is the magnetic fields and distances generated by my code. At the bottom is the magnetic field at 45 degrees at distance d. Analysis. From the experiment, the experimental magnetic field is roughly 5.38 times 10 to the negative 5, and from the coding, the simulated magnetic field is roughly 2.45 times 10 to the negative 5. Conclusion. The experimental and simulated magnetic fields are within the same order of magnitude, substantiating a degree of accuracy. However, this experimental magnetic field is much greater than the simulated magnetic field. And this is part of the similarities and differences, as the simulated magnetic field is roughly 45.54% of the experimental magnetic field, presenting possible flaws in the experimental procedure. The assumptions made were that there is no magnetic interference during the experimental lab and that magnetic north is accounted for in the experiment. The potential errors include that magnetic interference from nearby electrical objects could have occurred, and the exact distances may not have been recorded completely accurately during the experimental portion of the lab, both of these causing major differences in data. According to this what-if question, the x and y components of the magnetic field calculated in this experiment would change, since magnetic north would now be playing a role in both of the two components, as it is not only purely in one direction now. And according to this what-if question, by putting two identical magnets end-to-end and redoing the experiment, the new magnetic field value found would be greater as both magnets would contribute an additive magnetic field. In conclusion, overall, an experiment was conducted using a bar magnet and a magnetometer, and the magnetic field off-axis of a bar magnet was determined, both in experimental and simulated coding aspect. From experimental, it was 5.38 times 10 to the negative 5, and from simulations, it was 2.45 times 10 to the negative 5. Thank you.